So we're doing worksheet basics of polynomials, graphing, including transformations for Mac 1140 pre-calculus. We're going to start by looking at question 1. It's asking us, what is the order in which you should transform a graph? So you should always start with your horizontal, which is your x values. This gives you a really good starting point to work off of. Then you should always move on to stretch and compression because you want to know if your graph gets bigger or if it gets smaller. Then from there, you're able to go into reflection, which is either going to be across the x or y axis. And lastly, you should do your vertical transformations, which are your y values. So let's figure out and determine which one of these options fits our guidelines. So looking at A, we can see that it is horizontal and then vertical, stretch, compression, reflection. We already know that that's wrong because instead of going from horizontal to stretch, it goes from horizontal to vertical, so we can cancel that out. Next is B, which starts with vertical, which is an automatic cancellation because that's the last step. Next is C, which is horizontal, stretch, compression, reflection, vertical. This is exactly our steps that we need to take. So we know that the answer is going to be C. Moving on to question 2, it's asking what are 3 examples of a parent function. A parent function is a function that has no transformations. So going off the top of my head, I know that automatically we have a square function, which is y is equal to x squared. We have a cube function, which is y is equal to x cubed. And another common one you'll see is a root function, which is y is equal to the square root of x. So now that we know the correct order of graphing and a few examples of a parent function, let's go ahead and move into the next section of problems. Looking at question number 3, it's asking us to graph the function f of x is equal to x squared. Now this is in function notation, so f of x is the same thing as writing y. So looking at this, we can see that it has no transformations on it. It has no extra numbers, plus or minus symbols, nothing attached to the x value. So we can just go ahead and make a standard x, y table because this is a parent function. I like working with the numbers -2 to +2 for this type of function just because they're easy to work with. So I'm going to go ahead and plug those in to my function so I know what my y values are going to be. So when we plug it in, we'll get f of -2 is equal to -2 squared. Negative times a negative is a positive. 2 times 2 is 4, as you know. We're just going to repeat this step for the next 3 values. So now that we've gone ahead and plugged the rest of our x values into our function to get the y values, we're going to graph this. Now we're going to go to the x-axis first. We're going to go -2, +4, -1, +1, 0, 0, 1, 1, 2, 4. And as you can see, this makes your standard parabola without any transformations. So this is a parent function for a parabola. So now let's go ahead and look at question number 4. And again, it's asking us to graph the function f of x is equal to x cubed. As we can see again, there's no transformation, so this is a standard parent function of a cube function. So let's go right now making our x, y, t table. So again, I'm going to use the values -2 to +2. Then we're going to plug them into our function once again. Just f of -2 is equal to -2 cubed. Quick tip, any negative number raised to an odd power is going to be negative still. So this is going to be negative. So 2 times 2 times 2 is going to be 8. Again, follow that same rule from -1. -1 raised to the third power, which is -1 cubed. Again, it's odd power, stays negative, +1. Just repeat these steps for the next few values. Now that we have our list of values, we can graph it. So we're going to start at -2, -8, which is off my graph, but it looks like it's about right here. -1, 1, 0, 0, +1, 1, and then 2, 8, which is also good right there. So my best way to describe how this looks when it's graphed is like a little S. So this is what that function looks like graphed. So looking at question 5, again, it's asking us to graph the function which is f of x is equal to 2 times the argument of x plus 3 minus 1. Automatically, we can see that this involves transformations because it has transformations on both the outside of the argument and inside the argument. Now, a quick tip for graphing transformations that I like to follow is that any transformations that occur outside of the argument applies to your y values. And secondly, any transformations that occur inside your argument, or otherwise known as your parentheses, those change and transform your x values. So in this case, our argument is the x plus 3. So automatically know our x values are going to be transformed by the positive 3, and our y values are going to be transformed by the multiplication of 2 and the subtraction of 1. To start graphing this, I like to start by identifying my parent function. So in our case, since our given function has no powers or square root or absolute value signs, you know that our parent function is going to be y is equal to x. So based off of this, we can get a standard just xy table that we can work with. As always, I work with -2 to +2, so we're going to plug in these values for our parent function. So -2, again, replace it with every x value in the function, which is just x, so it's just -2, -1, 0, 1, 2. So now that we have our parent function xy table, we can apply our transformations to that. So remember what I put up here with our 1 and 2 steps? We're going to go and apply this over here with our new table. So how to set this up for how I graph it is I take my x values, and remember, transformations inside the argument, which is your parentheses set for in our case is x plus 3, is going to be a transformation for your x values. So you're going to take your transformation inside the argument, which is x plus 3, and you're going to set it equal to your parent function values. So this is what that looks like. X plus 3 is equal to -2. And now you're just going to solve for x on each of these. So when you do that, you will get the new x value. When you get -2 minus 3 is -5. Subtract 3. This gets you -4. And that is for our x values. When it comes to transforming our y values, it's anything outside the argument. So that's going to be our 2 and our -1. So how I write that, it's going to be your 2 times the y value of your parent minus 1. So we set that up for each of them. It's going to be 2 times -2 minus 1, 2 times -1 minus 1, 2 times 0 minus 1, 2 times 1 minus 1, and 2 times 0 minus 1. And we do each of these, 2 times -2, -4, -4 minus 1 is -5. 2 times -1 is -2, -2 minus 1, -3. 2 times 2 minus 1 is going to be 4 minus 1, which is 3. So now that we have our new values for our transformation, I'm going to go and rewrite them in a better table just so we can see them easier. So I'm just rewriting them so it looks a little bit neater. Now when we graph it, it's going to be -5, -5. So I see that is a straight line, so that is a linear function. We draw a line through it as best as we can. It's a little funky. We get this as our final graph. So now we're just looking at question 6, and it's asking us to graph the function f of x is equal to the argument of x minus 3 squared plus 2. So again, we're just going to find the parent function, and since we see that this is squared, we know that it is going to be a squared function. So again, repeat the same process. Once we know our parent function, we can go ahead and get an x, y table for that, so we can transform those values. Again, working from -2 to +2, we're going to plug these values into our parent function to solve for the y values. So once we have our parent value table, we can go ahead and make our table for our transformations. So again, when we set the transformations, anything that is inside the argument is our x values. So in our case, it's going to be the x minus 3 is equal to our parent value. So let's go ahead and write that out. X minus 3 is equal to -2. We're going to write that out for each one. So when we do this math and work it out, x plus 3, -2 plus 3 is going to be +1. we're going to do the same thing for each one of these x values. Now that we have our new x values, we can move on to our y values. So again, that's anything that happens outside of the argument. So it's going to be raised to the power of 2 plus 2 as our argument. So we're going to have our y values of our parent squared plus 2. So you write that out. It's going to be 4 squared plus 2. And then all of our parent y values. When we do that math, 4 squared is 16. 16 plus 2 is 18. 1 squared is 1, plus 2 is 3. Now that we have our new values, we can go ahead and graph them. But 2, 3 is going to be here. 3, 2 is going to be here. And then we have 4, 3, and 5, 18. So basically, I'm just going to draw it way up there. It's not realistic, but we know that this is transformed parabola.